continue from photoelectric effect.
Yeah. Okay. I want to
Yes, sir.
start from photoelectric effect. That's okay. You are given the right. So here, let me see the. This is a photoelectric effect. Okay. So this is a very good experiment regarding the quantum mechanics. So the quantum mechanics, whether the matter behaves, that means electromagnetic radiation behaves as a particle or a wave. Okay, so based on this concept we have a different phenomenons you can see here. Okay, so you know what is classical mechanics, what is quantum mechanics, already you have done what is that. Okay, so you know the black body radiation. So it is a body which absorbs all the wavelengths which are incident on it, right? Okay, then when it gives out all the wavelengths, when the black body is heated, when the black body is heated, it radiates all its what is observed the wavelength. That is the black body radiation, right? Can you give anybody the perfect black body radiation example? Perfect. I think no perfect. At least ideal. No. Very good. No answer means all are perfect, right? Okay, leave it. So what is Planck's law? Planck's law. Max Planck has given some phenomenon, isn't it? Okay, based on Einstein's theory, E is equal to h mu, and mu can be written by as h c by lambda. Okay, nobody is responding. Okay, I'll ask some questions in between. So if you're not responding, so when I discuss the photoelectric effect, I'll call according to rule number wise, you have to answer. Okay, so that is better, I think, right? So you can see here, photoelectric effect. This is the photoelectric effect where it gives the matter has a particle nature, right? Then regarding quantum effect also gives about the particle nature. But coming to the wave particle duality, it shows both the phenomena. The matter sometimes behave as a particle, sometimes behave as a wave, that is electromagnetic radiation. So generally we speak about electromagnetic radiation as a particle. The particle is nothing but photon. Photon is nothing but wave packet. Quanta, we call it as quanta. Okay, so one photon contains one wave packet. Keep it in mind, right? Then following by de Broglie's hypothesis. That means dual nature of the electromagnetic radiance. That means sometimes it has as a particle, sometimes it acts as a wave. Okay, so based on this hypothesis, Davison and Germer experiment have verified this hypothesis. Not only Davison Germer experiment, but also J.J. Thomson also given the experimental verification. Also you have find the de Broglie wavelength value also. Okay, but in your syllabus we don't have that Thomson effect, J.J. Thomson effect. So you know Heisenberg uncertainty principle. That means, okay, so two parameters. Okay, uncertainty in position, certainty in momentum. That is approximately equals to Planck's constant. Okay, you have that one. So coming to the Bohr's interpretation of wave function, that is Bohr's concept. How can you interpret the Heisenberg uncertainty principle? And lastly, you come under Schrodinger time independent equation. We have a time dependent, time independent equations. Then lastly, based on this Schrodinger, we have a particle in a potential box. So let me start with the photoelectric effect, right? Yeah, you can see the group of scientists who was given a tremendous uh, what game for the quantum mechanics, isn't it? They have different principles and phenomena and even experimental verification. You can see here. Okay, now he is the de Broglie, isn't it? De Broglie, right? And he has the Huygens, Isaac Newton, Davison is the Davison and Germer, both you have here. Okay, he is the Schrodinger. Schrodinger is the Schrodinger, and he is Compton. You're going to Compton effect, right? So you can see the group of he is the J.J. Thomson. Sorry, J.J. Thomson is the Max Planck. Is the Rutherford. Okay, you have a different scientist. What you have here. Okay, so let me start my here. So already I think this is done. So you can have the color temperature, right? And this is the spectral radiance of the black body radiations. Planck's. So this is the Planck's law, what you have studied. So Planck's constant H, you have a value for that one, right? So this is ordinary pendulum, what you have. And this is hydrogen atom. Now you can have a beautiful picture here. This is a uh, conversation between the Max Planck and the Einstein when they are going to have the quantum mechanics concept, isn't it? That is photoelectric effect, isn't it? Now, coming to the photoelectric effect. So all of you please concentrate what I'm going to have. So if you are interested, you can copy. So I may ask the questions in a little of my lecture. So be alert, right? So what is photoelectric effect, right? So let me have uh, a simple diagram here. You can have a simple diagram here. So I have taken a metal surface. I'm taking a metal surface. Okay. So when an incident light, that means a number of photons are incident on the metal surfaces, what happens? The electrons which are present in the metal surfaces absorbs the photon energy and the electrons get knocked out from the metal surface. So that is called ejected photoelectron. So why we specially call it as a photoelectron? Because the electron get ejected because of photons incident on the metal surface. You're right. Once again, I repeat, when the light is incident on a metal surface, that is photons, isn't it? The electrons which are present on the metal surfaces absorbs the photon energy. The electrons get knocked out from the metal surface. Sorry, not from the surface. So that is called ejected photoelectron. Particularly, we call it as a photoelectron. So what is photoelectric effect? Let me have the definition here. The phenomenon of emission of electrons from the metal surface exposed to light. That means high suitable of energy. So why we are saying high suitable frequency is that what? Every metal surface has its own frequency, isn't it? Okay. Why? Because the incident photon should be have more high frequency. Then only the electron will be ejected. So why? Because I'll tell you later in the next slide. So let me complete the definition. The phenomenon of emission of electrons from the metal surface when a light is incident on it is nothing but photoelectric effect, or we can say the electrons emitted in this process are known as photoelectrons. That's why we call it as ejected photoelectron. And the current which is constituent by the electrons, that means that is photoelectron, is nothing but photoelectric current. This phenomenon also known as photoemission. So in this we spell all it is photo, ejected photoelectron, photoelectric effect, photoelectrons, photo emission, right? Okay, so here this is not so simple. That means every metal surface does not emit any photoelectron. Why? Because it should be, the frequency should be greater than threshold frequency. Then only the electron can be ejected. You are getting? Okay. Suppose you have a photon, that is photon is incident. Some you have a value of some energy, that is 11 electron volts of energy is of photon. Okay, the electrons which are present in the metal surfaces should be have frequency greater than threshold frequency. So what is this threshold frequency? So if the incident photon should be greater than threshold frequency, then only the photoelectric effect exists. So let me have what is this threshold frequency? Okay, right? Now let
Sir,
me have some development.
sir,
Yes.
someone wants to join it seems, sir.
No, no, there is no chance. Already I have waited for 5 minutes. Let them have that. Okay.
Okay, sir.
There is the development here. So here the first is Newton corpuscular theory. Everybody you know, the particle initially they don't have electrons, neutrons, they don't have any idea. Okay, so Newton has supposed to be have that the matter is nothing but it is a tiny particles. So why? And also he said that why the matter is in different colors. He said that because of size of the tiny particles there are different colors. And he also says that the tiny particles are corpuscles we call it as. Okay, according to his theory, but it is failed to explain of that one. Then Huygens wave theory, everybody you know. So he has supported interference, that means wave theory. So we can say the matter acts as a wave, isn't it, instead of particle. Okay, so interference, diffraction, polarization. So what is interference? Superposition of two waves. Okay, and what is diffraction? The bending of light ray at the obstacles of a, sorry, the bending of light rays at the corners of an obstacle is nothing but diffraction. Then coming to the polarization, it's is a confined to single direction, isn't it? So unpolarized light is nothing but sunlight or tube light. Why? Because every ray is scattered in all directions. But in polarization, the ray is scattered only in one direction. That is nothing but polarization. So all these three phenomena based on wave theory. Then coming to the Maxwell's electromagnetic theory, already you have studied. And lastly, just we have to go with that photoelectric effect. Here, in this photoelectric effect, first was introduced by Hedge, isn't it? Experimentally in 1886. Okay. So based on his that the matter is nothing but acts as a particle, not a wave, isn't it? It acts as a particle. Both quantum and photoelectric effects, sorry, Compton and photoelectric effect based on matter assumed to be as a particle, not a wave. So let me see that what you have here. Now coming to the history of photoelectric effect, just now I said now the first photoelectric effect was introduced by Frank Halvax, then later he can Hertz. Okay, so all this already we have discussed about that one. Now, coming to the, just now we said photoelectric effect, photoelectrons, photo emission. Then what are photons? So you know electrons, protons, isn't it? Then additional, what is this photon? Just now I said now photons is nothing but a wave packet. It contains a quanta, we call it as quanta. Okay, it is a energy. It contains some photon is nothing but it's a wave packet. In packet you have so many energies, isn't it? So here we can say the radiant energy is quantized into localized bundles, that means energy bundles moving with a velocity c and having energy proportional to frequency. So you hear that this is the equation, that is energy of the photon is given as that is h into mu. So you can recollect this equation is belongs to Maxwell's Planck's law, isn't it? Max Planck has given this condition. So we can assume that the energy of the photon is nothing but product of Planck's constant into frequency frequency of the light. Light is nothing but it contains photons. Photons are nothing but wave packets, that is quanta. So these particles like bundles, that means quanta, are called photons. Okay, so in this electric process, one photon is completely absorbed by one electron. Keep it in mind. Okay, so that means one photon is incident on the metal surface. Okay, right? That complete photon is absorbed by one electron and get knocked out from that one. Like that, you can have number of photons in the light itself. Okay, everything is clear,
Yes.
right?
Sir,
Yes, sir.
Yeah. Now let me have another definition. Let us so far we have discussed what is photon. Okay, now let me have explain what is work function. I think this is the first time you are hearing the term work function. Okay, so let me have that definition. So here in a metal, electrons are bound by attraction force of nucleus, you know that. Okay, so the electrons which are near to the nucleus bond very tightly. Why? Because there is some attractive force between that, force of attraction. But coming to when the last one, you can have a valence electrons, isn't it? Only those valence electrons are responsible for any properties of that material. So here the minimum energy required to pull out the electron from the metal surface is nothing but work function, isn't it? Suppose you have an electron which is bound to the nucleus, isn't it? To break that bond, we require some energy, isn't it? That energy is nothing but work function. It is the minimum energy required, okay, to pull out the electron from the metal surface is nothing but work function. Everything is clear, right? Now here, work function is nothing but it is a characteristic property of a material. That means different materials have different work function. Okay, now the unit of work function is measured in just like energy. We are saying minimum energy required, so we can say it is a work energy or work function. So it is measured in electron volts, isn't it? So how can you define 1 electron volts? That is equal to 1.6 into 10 to the power of minus 19. So what is this 1.6 minus 19? Can you remember the value of this one? Who?
charge of
Charge
electron.
of electron.
Very good, very good. 1 electron volt is equal to the charge of one electron. That is 1.6 into 10 to the power of minus 19. Okay, okay, you can have a good idea about work function, isn't it? Now you can see the table here. So you can have a different metals, isn't it? So these are single element, not the compound. We can say metal. So for cesium, the work function is 1.9. That means you can 1.9, if you the energy is greater than 1.9 only, the electron can come out from the metal surface. Similarly, you can have a list of elements here. See here. So these are the standard values for different metals, isn't it? I think platinum has greater work function. So you require more than 6.4 electron volts so that the electron come out of from that one. That means the photon should contains more energy, isn't it, to knock out the electron. That means it should be greater than 6.4, isn't it? Now you can see this first generalized expression you can have here. Just this is the overall understanding of this one. Now you can have a potassium. See here. What is the potassium? You have a 2.2 electron volts, isn't it? The work function of a potassium is nothing but 2.4 need to eject the electron. It should be greater than. So what you can have a three different rays is falling on the incident surface. First of all, you can see here. So just have incident a light whose wavelength is 700 nanometers, isn't it? With a 1.77 electron volts. So what happens? No electrons can be ejected, isn't it? Then similarly, I'm going for 550 nanometers, whose energy is 2.25 electron volts. That means a single electron is ejected with a velocity of maximum 2.96 into 10 to the power of 5 meters per second. Similarly, when I incident 400 nanometers with the high energy, that is 3.1 electron volts, so electron is ejected with a greater velocity, that is 6.22 into 10 to the power of minus meters per second. So what you understand from this diagram, anyone in the class? I've given three rays with different wavelengths, different energy, have taken a potassium metal surface. So what you understand from this? Anyone, please?
More the energy given, more is the velocity of the ejected electron.
Right. Okay. More energy you are saying, isn't it? That energy is nothing but threshold frequency or threshold energy, you can call it as. If it is greater than that only, that means in the first case, you have no electrons. And one thing I want to ask, so you have a spectral lines. Everybody hear about the spectral lines? Band.
Yes, sir.
Yes, sir.
Yeah, that is with GR, what you have, with GR, 7 colors. So which color has low wavelength?
Violet.
Violet.
Violet. That means more frequency, isn't it?
Yes,
Yes,
sir.
sir.
Yes,
Yes,
sir.
sir.
Isn't it? Inversely proportional. If the wavelength is less, frequency will be more. Now you can understand here. This is the red color and this is the violet color. Okay. So you can see the wavelength is more, less frequency. Okay. You're getting?
Yes,
Yes, sir.
sir.
Yes,
Yeah.
sir.
So more the frequency, more the ejected electrons what you. That's why we have given here three different colors. The rays is three different colors, isn't it? So this is a red color and this is a violet color. You can see here the violet is having more frequency, so you can eject the electrons with a greater frequency, such greater velocity of that one. Okay, so I mean to say that every particle, that means wave function, is a characteristic property of metal, isn't it? So you have to consider the metals works function. Okay, so the how much incident line can be incident, that one, then only you get the photoelectric effect. Now these electrons are responsible for the photoelectric effect. We can call it as ejected photoelectrons, isn't it? The current in the circuit is due to photoelectrons. That means photoelectric effect. That means the conduction is due to photoelectrons only, isn't it? Keep it in mind. Okay. So let me go the other one. Now, coming to the properties of photons. What are the properties of photons here? Okay. Here, all quantum numbers are zero, right? Here, a photon does not have any mass. Do you agree?
Yes, sir.
Right. Charge?
No, sir.
Yeah. And they do not reflect it, does not affect by the magnetic and electric field. This is most important, isn't it? This is the most important. The photon does not possess mass, charge, or they never affected by the electric and magnetic field. Right. Now here, the photon moves in the speed of light at empty space. Right? Yeah, during the interaction of matters with the radiation, radiation behaves as it is made up of small particles called photons. That means you are giving the definition of that one. Okay, so we can say the photons are virtual particles. And one thing most important is, so photon energy is directly proportional to its frequency and inversely proportional to its wavelength. So keep it in mind, right? Then coming to the momentum and energy of photons are related, you given you, that is E is equal to PC, isn't it? Where P is nothing but magnitude of the momentum, where C is nothing but speed of the light. Okay, so these are some properties of photons. Now, how wave theory failed to explain this photoelectric effect? So let me have some simple here, just an outline of that one. Okay, so here on increasing the intensity at constant frequency, photocurrent increases. Okay, just now I said the photo current depends upon frequency, isn't that? It means more the frequency, more the current, and more the intensity, more the current, isn't it? So this was not explained by the wave intensity. It is related as, you can have an equation for that one. Now coming to the frequency, as a frequency variation at constant intensity, that means keeping intensity constant, changing the frequency. So what happens? Stopping potential, I'll tell you later what is stopping potential. Okay, so here this was not explained for a wave frequency. It is related to the number of photoelectrons. Basically the number of photoelectrons depends upon intensity, isn't it? Keep it in mind. Okay, as the intensity is more, number of photons will be more. Okay, right. And one thing, if the frequency is more, the photocurrent is more, but the photocurrent never depends upon intensity. It depends upon only frequency. So there are some points you have to remember. Okay, now coming to the Einstein's, that is a particle approach. So he says that light consists of bundle of energy known as photon or quanta. First, he is the person. First, he is the person to explain about that particle nature of the electromagnetic radiation. So he has given E is equal to hf. H is the Planck's constant, F is the frequency. Now here, the energy required to emit electron from the metal surface, that we have already discussed, that is wave work function. So that is represented as phi. All of you keep it in mind. This work function is represented as phi or W. Both terminology we use. That is equal to H into F naught, right? So the remaining part will be kinetic energy of the emitted electron, isn't it? Once the electron absorbs the photon energy, some energy is utilized for the knockout of the electron. The other energy is absorbed by two kinetic energy. Okay, so once again repeat, the electron absorbs the photon. Okay, so some part of energy is required to knock out the electron, and other part will be for gaining the for gaining the kinetic energy, isn't it? So it utilizes the two energies here. Two energies are transformed. One is to knock out, the other is to gain the kinetic energy. That means recoil of the electron, we call it as. So that is given as kinetic energy is equal to hf. Hf is nothing but minus phi. This is the work function. So what you get, phi is nothing but h into f naught. So when you take h common, that is f minus f naught. This is the whatever the total energy, that means gained by the emitted electron, you can find like this. Okay, now coming to here, when the negative potential on the photoelectron receiving the plate equal to kinetic energy of the emitted electron, no photoelectron will flow in the circuit. So that is given that when kinetic energy is equal to EV naught, that means no photocurrent will be exist for that one. So for this phenomenon, he got the Nobel Prize in 1921. That is for Einstein. Okay. Then coming to here, photon theory. First, wave theory based on photoelectric effect. Next, Einstein's particle photoelectric theory. And the third one, photon theory explains what basically. So here, particle-particle interaction, that means electromagnetic radiation is assumed to be particle, but here the interaction is also between the particle and the particle. Now you can have here, on increasing the intensity, that means keeping frequency constant, increasing the intensity, the photocurrent is increased. This was explained perfectly by the photoelectric, that means photon theory. Next, keeping the keeping the intensity constant, changing the frequency. So here the stopping potential increases. So what is the stopping potential? That is more negative potential required to stop the photocurrent, isn't it? So this explained as a frequency is related to kinetic energy of the electrons. Okay. Now coming to the definitions, most important here, the photoelectric effect is threshold energy for the photoelectric effect. This is the most important parameter. So what we call it as a threshold energy. So what, let me have explain what is that threshold energy. So to occur the photoelectric effect here, the photons that are incident on the surface must carry some sufficient energy. Okay, to overcome the attractive forces between inside the atom. Okay, that means which are bound to the nucleus. Okay, that is the most basic phenomenon of that one. Here, the minimum amount of energy required to remove an electron from the metal is nothing but threshold energy, that we call it as work function also. Okay, work function or threshold energy gives the same meaning, isn't it? The minimum amount of energy required to remove an electron from the metal surface is nothing but threshold energy. Just now I said na, it is represented as a phi. Okay, so here the photon to process a energy equal to threshold energy, its frequency must be equal to threshold frequency, isn't it? For the photo emission process, isn't it? The frequency must be greater than the threshold frequency, then only the photo emission occurs. If the frequency is less than threshold frequency, there is no emission of electrons or knockout from the electron. Keep it in mind. So which is minimum energy of a light required for photoelectric effect to occur? That is nothing but threshold frequency. Once again repeat, it is a minimum energy, sorry, it is a minimum frequency required for a light for the photoelectric effect to occur is nothing but threshold frequency, isn't it? Just now I said na, threshold frequency. The frequency required should be greater than threshold frequency. There is an emission of photo emission, we can say, isn't it? Now here, let me have a different cases here. So let me have a formula which is written here. You can have that one. So here, the threshold frequency is usually denoted by symbol mu h. That is threshold. TH is nothing but suffix, you can see. TH is nothing but threshold. So this symbol is represented for the frequency. And the associated wavelength is called threshold wavelength. Why? Because frequency and wavelength are inversely proportionals. So we can assign it is as a threshold wavelength. So for this donation, for this symbol representation, we have a lambda that is called TH, that is threshold wavelength. Okay. Now the relationship between the threshold energy and the threshold frequency can be expressed as, isn't it? So we can have phi is nothing but energy, threshold energy. So it is basically represented as E is equal to h mu. In the same way, for threshold energy, we have a phi that is equal to h into threshold frequency. So this frequency can be written in terms of wavelength. What can you write? C by lambda, isn't it? So this is the basic expression for the threshold energy. Everybody should note down that. Why? Because tomorrow I'll ask the question for you, right? Okay. So this is called threshold energy. All of you note it down. The running note should be there. Okay. So we have studied what is photon, what is work function, and what is threshold energy, and what is threshold frequency, and what is threshold wavelength. And you have given the relation between the threshold energy and the frequency, isn't it? That is the formula we can have here. Okay. Next, what is the relation between the frequency of the incident photon and the kinetic energy of the emitted photoelectron? So you have a clear idea. This is the most important. Everybody should copy this one, right? So let me have the relation between, once again, frequency of the incident photon and kinetic energy of the emitted photoelectron. So what gives basically relation between them, isn't it? Now you can have energy of the photon is equal to, this is called work energy, sorry, threshold energy plus energy of the electron. So you can see here, this is the incident photon. This is the energy of the incident photon. So when the photon is incident on the metal surface, isn't it? The minimum energy required to knock out the electron is nothing but threshold energy plus some part will be utilized for the kinetic energy of the electron, that is E, isn't it? Two parts you can use. This photon energy can be utilized into two ways. One is knock out the electron, one is kinetic energy of that one, isn't it? So here we can write E is equal to energy of the photon is nothing but H mu. This is the generalized expression for that one. So what is the work threshold energy that is given in the previous one? Okay, this is one, that is H into mu TH, that we have written. Just now I said now, when the electron absorbs the photon energy, one part will be utilized for the knockout of the electron, the other part is utilized to transform in the form of kinetic energy of the electron, not the photon. That means of the electron, that is given by half MeV square. That's why I have written this is the mass of the electron, ejected electron, that is called. This is the velocity of the electron, not the photon. Already is there. This photon is there, already is there, right? So this is the most important expression, that is relation between the frequency of incident photon and the kinetic energy of the emitted photoelectron, isn't it? Right? So here we can have that. You can have the different terminology what you have here. Okay. So this is the most important derivation. So you can have the problems in this by this expression, right? So everybody has copied this one.
Yes, sir.
Right. Very good. So let me have the next now. So just now we have an expression here. This one, this diagram I have noted in different another way. So we have a different colors. So we can have here also the same concept. So you can have here, this is the one metal surface. You have three metal surfaces, but means we take one metal surfaces. So on that we have a different energy of incident light here. The first case here, the incident light frequency, what you are going to incident light frequency is less than the threshold frequency. That means no electrons can emit, isn't it? Then coming to here, so if the low energy incident light, that means photoelectrons with the low kinetic energy are emitted in between. That means if the frequency is greater than frequency, you can see high energy incident light. That means the incident energy should be more to overcome the threshold frequency. Then only the electrons get photo emission process exists in that one. Suppose if you take a metal surface, if you incident the red light, suppose red light of frequency, you can have incident that one. So why? Because the frequency is very less, so there is a no photo emission. If you take violet color, that means high frequency, here more number of photo emission occurs. If you take X-rays, X-rays have high frequency. So easily you can have the photo emission is more as compared to other one, but because X-rays have high frequency, isn't it? Okay. Now here is the what we have, the total picturization of that one and the corresponding. So we can say here the photoelectric does not occur when the red light strikes the metal surfaces, right? So because the frequency of the red light is lower than the threshold frequency, that is one. Next, the photoelectric effect occurs when green light strikes the metal surface and photoelectrons are emitted. Why you said green color? So the frequency is intermediate. The value of green is intermediate between the violet and red color. So that's we can say the photo just emitted of that one. So if you take the other color, so whose kinetic higher, that is blue light. So we can say basically violet light, it contains high frequency. So we can say that the light is greater frequency than the green light. Okay. Now coming to the what are the minimum condition for photoelectric effect? What are the minimum conditions? So first one is threshold frequency, and one is next is threshold wavelength. So how they are related? Let me have some cases you can see here. Suppose it is the minimum energy of the incident light or a radiation that will produce a photoelectric effect, that is ejection of photoelectrons from the metal surface. Okay, so that is called threshold frequency for the metal. You please copy this definition. So it is a minimum frequency of incident light that are radiation will produce a photoelectric effect. That is ejection of photoelectrons from the metal surface is known as threshold frequency of the metal. Okay, now it is a constant for a specific metal but may be different for different metal. Just now said na, just now you seen the list of here, list of that one. That means indirectly you can say this is the threshold frequency, isn't it? So for different metals, you have a different threshold frequency of that one. Now, if the frequency of the incident photon, we can say if the rho is the frequency of the photon, incident photon, and this is the threshold frequency. So let me have the three cases. First one, if the frequency of incident photon is less than threshold frequency, so there is no ejection of photoelectrons and there is no photoelectric effect. Keep it in mind. That is first case. The second case, if the frequency of the incident photon is equal to threshold frequency, the photoelectrons are just ejected from the metal surface. So in this, the kinetic energy of the electron is zero. Next, third case, if the frequency of the incident photon is greater than the threshold frequency, okay, the photoelectrons will come out of the surface along with its kinetic energy. Okay, this is very clear, everyone?
Yes, sir.
Right. Now, let me have threshold wavelength. What is threshold wavelength? Isn't it? Now here, during the emission of electrons, a metal surface corresponding to greatest wavelength to the incident light is known as threshold wavelength. So you have a formula for that one. So lambda is equal to C by mu, isn't it? Now, let me have the three cases in this also. That means for a wavelength above the threshold, there will be no photoelectron emission. Whether this sentence is correct? Once again, I repeat this one. For the wavelengths above this threshold, there will be no photo emission. Okay, how this is possible? Now let me have, if the lambda is the wavelength of the incident photon, that means if the wavelength is less than the threshold frequency, the photoelectric effect will take place and ejected electron will possess kinetic energy. Why? Because it is the inverse of the threshold frequency. If the wavelength is more, frequency will be less. If the wavelength will be more, frequency will be less. If the wavelength will be less, the frequency will be more. That is vice versa. In the previous case, okay? In the previous case also, you have this one. If its frequency is less than threshold frequency, there is no projection at small. If the wavelength is less than threshold frequency, you can see what happens here. Okay? Now you can see no photoelectric. That means inverse of that one, same data will be given here, isn't it? So keep it in mind. Next, work function or threshold energy. Just now I said na, threshold energy, work function give the same meaning. So what happens here? So you can have here, this is the formula what already we have discussed here. Now suppose if E is the energy of the incident photon, so how it is related to the work function, isn't it? Now if E is less than work function, that means the energy is less than the work function of that one, no photoelectric effect will be take place, isn't it? So you know what is work function? Work function is nothing but this a minimum energy required to knock out the electron from the metal surface, isn't it? So if energy is equal to work function or threshold energy, just photoelectric effect will take place, but the kinetic energy will be zero. That means it will be the that one. So if energy is greater than threshold frequency, so threshold energy. So what happens? The photoelectric will takes place with a question of kinetic energy. That means it have it gains some kinetic energy. So these are the factors which affect the photoelectric effect. First one is threshold. Okay, threshold frequency, you have a three cases. Next, threshold wavelength, we have a three cases with the formula. Next, work function, we have a formula and the three cases, isn't it? So these are the three factors which affect the photoelectric effect. Okay, now coming to the actual. So what is the photoelectric formula? You can see this slide. Okay, you copy please all of you this one. So according to Einstein's explanation of the photoelectric effect, and just now I given the energy of the photon is equal to energy needed to remove an electron plus kinetic energy of the emitted electron. Have you seen this one now? The previous slide, do you remember?
Yes, sir.
Yeah, I'll show once again, please, if you doesn't remember. This is the equation what you have. This is the photoelectric effect formula, isn't it? They may ask in the objective type, please write the photoelectric effect formula, means you have to write this one. So we can have the phi or W gives the same meaning. W or phi gives the same meaning. So that I have written separately here. So you can have here. So H mu is equal to W plus E. Okay. So this is the photoelectric effect formula, right? So let me have the setup, how you produce the photo electric, that means current in a circuit. Now basically, so far we have discussed about these two only. This is the metal, just this is the metal what you have discussed, that is photoelectric effect, this one. So far we have considered the theory what is happening here. So for the production of photocurrent, this is the setup what we have. So in this setup, let me have explained this one. So this is the evacuated glass chamber. So in this glass chamber, we can have a cathode and an anode. So cathode is nothing but a metal surface, isn't it? So where the photo emission takes place here. So what is happening? A incident light is falling on this metal surface. Okay. So here the uh, frequency of this incident photon should be greater than the threshold frequency. Then only the four electrons get knocked out from the atoms and possess some kinetic energy, isn't it? Then what is the purpose of this anode is, this is attract the electrons. This attracts the electrons. That means these electrons move towards the anode and transform to the commutator. Now you can see here, you can have in the circuit, one is the microammeter, which is variable, and you have a voltmeter and you have a battery. So what is the use of this battery is that one, to increase the potential difference between cathode and anode. Why? Because more potential you applied, more photoelectrons you get, more photocurrent you can get. That means number of photon increases, the number of photo emission also increases. That means more current is produced in the circuit. Once again I repeat, if you the purpose of this voltage is to accelerate the electrons fastly towards the anode, isn't it? Now you can see here, V is the potential applied between the emitter, that is C, and the collector. We can have emitter and collector here. So where A is connected to the positive terminal and C is connected to the negative terminal. This is called accelerating potential, and reverse is also known as retarding potential. That means positive is connected to the C and negative is connected to A. That is called retarding potential. Now let me have here, once again I repeat, A is connected to positive and C is connected to negative. See here. Okay. Right. Now let me show the other one. Now coming to here, observations of photoelectric effect. So here the photoelectric current starts flowing as soon as the light supply is turned on. That means light gets starting. So actually, the time lag between the shining of the light and the emission of electrons is less than 3 into 10 to the power minus seconds. That means as soon as the light falls on the metal surface, it takes some time. That duration time is nothing but 3 into 10 to the power of minus 9 seconds. Then after the emission starts, that means the electron get out from that one. Okay. Now here, the minimum energy of light required to eject the electron from the metal surface is nothing but threshold frequency. That is V naught. Already we have that one. So here we can write in terms of work function, W function is equal to H into mu naught, isn't it? And corresponding wavelength also we can call it as a cutoff wavelength. So that can be written as, rearrange this one. Lambda C is equal to C by V naught. That gives to V naught is nothing but we can have the work function or work energy, we call it as. So here the kinetic energy of the photoelectrons is independent of intensity. Just now I said now, isn't it? It depends upon only the frequency. Intensity only depends upon number of photons ejected, number of photons. Intensity, more number of photons. But the kinetic energy depends upon only frequency. Keep it in mind. Okay. Once again, I repeat, please copy this one. Independent of kinetic energy is independent of intensity. Only depends upon frequency of light. Next, for a fixed frequency of light, the number of emitted photoelectrons is proportional to, just now I said, na, intensity depends upon the number of photoelectrons. So the photoelectric current increases linearly with intensity, not with the frequency. Chudandi, number of photoelectrons will be more photo emission, more current, photocurrent will be increases, isn't it? Okay, the kinetic energy depends upon frequency only, not by intensity. Next, the number of emitted photoelectrons depend upon intensity of light. That means more number of photoelectrons, more the current is produced in the circuit. Keep it in mind. Okay. Now here the photocurrent increases. Slide కనబడుతుందా మీ అందరికీ?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Yes, sir.
అదే నాకు డౌట్ వస్తుంది, 9:42 అయింది మరి ఇంకా కాలేదు అని. ఓకే, హియర్ the photocurrent increases with accelerating potential. One more thing, one parameter also you can have. The photocurrent increases with the accelerating potential, isn't it? Okay, so this current becomes maximum and known as saturation current. That means the photocurrent go on increases with the increasing of the intensity at particular limit. That means no current exists in that one. That is called saturation current, isn't it? Okay, here the saturation current increases with the intensity. Once again, okay, the number of photons depends upon intensity, that is one. The saturation current also depends upon intensity, but not depends upon frequency of light. So now you can see here, light intensity, electron current. See here, as the intensity is increasing, చూడండి increase అవుతూ ఉంటూ ఏమవుతుంది, electron current also increases and goes to peak point. So beyond that there is no increase in that one. That means this is called saturation current what we have. That means the frequency is greater than threshold frequency only, isn't it? This is happens. Now you can see the different collector plate retarding potential. So this is called stopping potential. I'll tell you what is here. Now you can have this one. What is saturation current? The photocurrent increases with the accelerating potential. That means, చూడండి ఇక్కడ, this is the accelerating potential. If you increase, what happens? The photocurrent increases. It's for certain positive terminal potential, positive potential of collector A, all the emitted photoelectrons are collected by A. So the current becomes maximum and known as saturation current, right? Now here, coming to the stopping potential or cutoff potential. Just now we have this one. What is stopping potential? Let me explain that also. Okay, for a particular frequency of light, the photocurrent found to decrease with the increase of retarding potential. Okay, so for a value of negative potential of collector, the current drops to 0. This is called stopping potential or cutoff potential. Okay, so it is depends upon only on frequency, not independent of light intensity. Once again, the saturation current, the number of photoelectrons depends upon intensity. So what are the factors which depend upon frequency? Kinetic energy, stopping potential. Okay, so keep it in mind, these two products. Okay, now how can you write that one? So EV naught is equal to K maximum, that is kinetic energy. What we call it as equal to V naught. It is the stopping potential into electron charge. This is an electron charge, very important. So this is the diagram what we have the saturation current here, isn't it? So everything is clear, right? Now, what are the laws of just overall of that one? So electrons are emitted instantly. Photocurrent is directly proportional to light intensity, and a threshold frequency, that means should be greater, then only the photo emission takes place. Then maximum kinetic energy depends upon frequency, but independent of intensity. So your stopping potential depends upon intensity, but is independent of frequency. Okay. Now, what are the factors affecting? We can have three factors: intensity of the incident radiation, potential difference between the metal plate and the collector, and the frequency of incident radiation. Okay, so you can have the different graphs of photoelectric equations. So one is energy versus frequency, and this is the what we call potential versus threshold one, and this is the saturation current intensity, and this is the stopping potential versus frequency, and this is the voltage versus current, that is VI characteristics, and this is also VI characteristics. Okay, now Einstein's photoelectric effect, what you have the final, this is the photoelectric effect formula. Okay, so I'm not going to detail, and these are the some comparison between. So coming to the applications, so where we use these applications is first one, solar cell, that is photo, that means from sunlight we produce current, that is most sun, and we also use in the satellite system. So you can see have the solar panels, and you can see the burglar alarms in the house, sensors we use, isn't it? So for the protection of the house, we use this alarm circuit what we have, and other one we can have these light sensitive detectors what we have the setup. Okay, so this is about what we have the photoelectric effect, right? So everybody is clear?
Yes,
Everybody is
sir.
clear?
Sir,
Yes,
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 sir.
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 Okay,
Yes,
so
sir.
tomorrow at what time you have a class? 11:40 kada? At what time you have? Unda re class unda?
11:40, sir.
Level 40.
Sir, 11:40.
Okay, I will take at 1:40. 1:40 is free slot na?
Yes, sir.
Okay, I'll take at 1:40. Why? Because 11:40 I have other class. So in the morning you have a PPS na?
Maths, sir.
Okay, okay, okay.
Sir,
Emma,
sir,
చెప్పండి.
yesterday maths ma'am said that Wednesday and Thursday at 1:40 ma'am will take.
ఎవరు ధనలక్ష్మి మేడమా?
Yes, sir. Ma'am will take extra class.
ఎక్స్ట్రా క్లాస్ తర్వాత తీసుకోమని చెప్పండి, సార్ తీసుకుంటాడని చెప్పండి. ఓకేనా? సాటర్డేస్ అట్లా తీసుకోమని చెప్పండి.
Oh,
ఓకే, సో వై బికాస్ ఇస్ అ రెగ్యులర్ క్లాస్ కాబట్టి ఐ వాంట్ గో 1:40. వై బికాస్ సిలబస్ ఇస్ లెస్. అడిగి చెప్పండి కీర్తి.
okay, sir.
మేడం మరి సార్ తీసుకుంటాడా
Okay,
అంటే
sir.
సార్ తీసుకుంటాడు అని చెప్పండి ఒకసారి. ఓకేనా?
మ్యామ్ మండే తీసుకోలేదు అని తీసుకుంటా అని చెప్పారు సార్.
మండే తీసుకుంటున్నా, మనకి టైం లేదు
నిన్న
కదా.
తీసుకోలేదు.
ఓ నిన్న తీసుకోలేదా? ఒకసారి అయితే అడగండి.
అవును సార్.
నాకు కంపల్సరీ కావాలి అంటే విల్ సీ అదర్ ఆల్టర్నేట్. ఓకే
ఓకే సార్.
ఓకే ఓకే. అండ్ మై డియర్ స్టూడెంట్స్, కాన్సెప్ట్ is very clear for you. If you have any doubts,
Yes,
you
sir.
can have my number. I think every number my number. You can have that one and you can ask the doubts. You can raise the doubts. So regarding this material, I'll send you I'll send you in other way. Okay, so don't worry about that one. Material is done, everything will be there. So let me have the attendance. Room number 501.
Present, sir.
501.
Present, sir.
గట్టిగా చెప్పాలి నాన్న, నేను అరుస్తున్నా చూడు
Present,
అప్పటి నుంచి.
sir.
అట్లా ప్లీజ్ ఫాలో హర్, మెల్లగా చెప్పకండి.